Section 3 of Chapter 5 is adding, subtracting, and multiplying polynomials. And you know that polynomials are just lists of terms, just like your binomials and trinomials that you've already added, subtracted, and multiplied. So we're going to do the same thing we've done before. We're just going to up the ante and make it a little bit more difficult. So when you're adding polynomials, just like when you're adding binomials or trinomials, you just combine the like terms. And when you've got polynomials, you've got more of them, so you can either do them like we've always done them horizontally, where you have to make sure to match up. We've got 2x cubes here, so you combine them together, or 2 and 3 here, so you've got 5x cubes all together. And find the x squares. You have 2 here and -4 here, so minus 2x squared. And the x terms, -3 and -1, they're both negative, so you add them. Minus 4x. And my constant terms, 5 and -7, combine those together and you have -2. So that's how you've always done binomials and trinomials. It's a little bit cumbersome with polynomials with more than 3 terms. So you can do this with binomials and trinomials if you wish, you can actually add those vertically. Just like with regular numbers where you have to line up the place values, you need to make sure to line up your like terms. In this case, we had a polynomial that did not have an x term, so we have to leave that blank. Be careful that you line them up properly so you don't add your -4 to the -3x, because those are not like terms. So once you've gotten your terms lined up, then you just add them. So you can, and in all honesty, you can add either direction because there's not going to be any carrying going on. So you can add left to right or right to left, whichever way you prefer. So 4 and -5 is -x cubed. 4 and -2 is plus 2x squared. The -3x stays the same because it's not added to anything. And 10 and -4 is plus 6. Easy sneezy, just combine like terms. Now, when you subtract polynomials, the hint I have here that you want to get in your notes, change all the signs in the subtracted polynomial. So that's the tricky part. You can do subtraction just like we've always done it, but I would actually suggest that if you're going to do that, that you take out the parentheses and then bring the negative all the way through that whole polynomial before you start combining those like terms. Because when you're subtracting a polynomial, remember, it's almost like you're multiplying that polynomial by -1 and then adding. So in this case, and what I've done is I prefer to do them vertically. So you've got 3y squared minus 4y plus 7 minus the quantity of 6y squared minus 6y minus 13. Here's what I do. Instead of trying to remember, okay, I'm subtracting, and so I just change the signs, and then I'm always adding, all right? So we're subtracting this, which means we're going to add the opposite of everything through here. So I'm going to change whatever sign it is, I'm going to change it to the opposite. And then I don't have to remember, am I adding or am I subtracting it? Just change the signs all the way through your second polynomial, and then you just add it just like this. So now you've got a -3y squared plus 2y plus 20, and you're finished. All right? So adding, combine like terms, subtracting, combine like terms after you change all of the signs in your second polynomial. All right? Multiplying is a little bit trickier. Multiplying, remember, you've got to multiply every part by every part. Just like if you're multiplying by binomials, when we do FOIL, you're not going to do FOIL, but you are going to do FOIL. It's like an expanded version of FOIL, every part of every part. So the 5 has to be multiplied by everything in this trinomial, and the x needs to be multiplied by everything. So we've got 5 times x squared is 5x squared. -x times, sorry, 5. We're doing the 5 first. Whew. So 5 times -2x is -10x. 5 times 3 is 15. So you can see how it can get a little bit tricky. You've got to start with one and stick with it, multiply by everything. And then what I do is I move to the other term, and I actually create a vertical addition problem, because we're going to combine the like terms. So I take the -x times your x squared, and I put it underneath here. isn't another x cubed, so I'm going to bump it over here and say this is negative x cubed, negative x times x squared. Now you're going to multiply negative x times negative 2x. Negative times a negative is a positive 2x squared, and I'm going to put it right underneath my squared term here. And then the negative x times 3 is minus 3x. And if you just line it up, now it's almost like just a regular multiplication problem. So you bring down your 15, and negative 10 and negative 3 is negative 13x. 5 and 2 is 7x squared, and then negative x cubed. All right, so remember to multiply every part by every part. You can also do that, let's see, you can also do that in a vertical format, and then it just looks a little bit more like what a multiplication problem, a regular multiplication problem with regular numbers would look like. 3x squared plus 3x plus 5 times 2x plus 3. You can either set this up like we did here, or you can multiply it this way. So if you're going to do this, you just multiply every part by every part. It might be easier to line up for you this way. 3 times 5 is 15. 3 times 3x is 9x. 3 times 3 again is 9, and we've got an x squared term. Don't lose your signs in between. Now when you multiply that, you don't have to worry about zeros, because if you're lining up your like terms, they're going to line up in the right place. So 2x times 5 is a 10x. So you find your x terms, 10x, and it's positive. 2x times 3x is going to be a 6x squared, and it's positive. And 2x times 3x squared is going to be a 6x cubed. And then just add them. And once again, you can add either way. So let's go this way this time. 6x cubed plus 9, 11, 12, 13, 14, 15, x squared plus 19x plus 15. All right? So it works exactly. It's the same thing. So whichever way you prefer to do it is totally fine. All right? Just be aware that either way works. All right. Next, what if we want to multiply 3 binomials? We sure can do that. We're just going to multiply through and say, well, you can actually multiply x minus 1 times x minus 1, but if you can remember that x minus 1 times x minus 1 is the same as x minus 1 squared, if you can remember those special products and say, oh, I recognize that. That's x squared minus 2x plus 1 squared is 1. All right? And then you're going to multiply that by x plus 2, and you can either multiply this vertically or horizontally, whichever way you prefer. So once again, go ahead and pause it and do this one by yourself, all right? And come back, and I'll go quick. All right, x times x squared is x cubed minus 2x squared plus x plus 2x squared minus 4x plus 2 is x cubed. This term drops out because you've got a negative 2x squared and a positive 2x squared. Minus 3x plus 2 is your final answer. All right? So when you're multiplying 3 binomials, it just means that you need to do the FOIL twice, or multiply every part of every part twice. You can't do all 3 at one time. So you're going to multiply these 2 together and then take that product and multiply that by your next term. So if you didn't recognize this special product, you could just FOIL it. X times x is x squared, negative x, negative x, negative x, and negative x is negative 2x, and 1 times 1 is 1. That's where I got that. So speaking of special products, these would be good for you to remember. So let's just go back to them. If you don't have them in your notes already or in your memory, one or the other or both, make sure you get them down now. These special patterns for squares, if you remember, are the a plus b, a minus b is just a squared minus b squared, because those middle terms drop out, remember? If you square a plus b, the quantity, you're going to end up with a squared plus 2ab, so you'll multiply the two terms together and take that times 2, and then your last term squared. If you've got a minus b quantity squared, remember that's the first term squared, and then you're going to take the two middle terms times each other and multiply that by 2, and so that answer will be negative because that b is negative. So negative 2ab plus your last term squared. So you should have seen these already. These should look familiar. If you don't have them in there, pause and get them in your notes. The new ones that you'll need to know now have to do with cubes. And these will also be helpful to remember so that you don't have to actually, if you don't remember them, you can always just multiply it out 3 times and that's fine. So a plus b cubed, remember, is a plus b times a plus b times a plus b, but it's the same thing 3 times. So the pattern for that is a cubed plus 3a squared times b. So you're going to take the a squared times b and that whole product times 3. And then you're going to take 3ab squared, which means you're going to take the b and square it times the a and that whole product times 3. And then your last term is going to be your last term cubed. All right? Same type of thing happens if it's a minus b, so some number minus another number. You're going to have a cubed minus 3 times a squared b. The reason this is negative is because your second term is negative. And this one is positive because your second term is squared. So a negative b squared is going to give you a positive answer here. So plus 3ab squared minus the last term squared. And the reason now this is negative is because you've got an odd exponent. All right, so let's use some of these special patterns and do a few of those so that you can see how helpful they are. All right, I'm going to start writing them. If you know them, just get busy doing them. And you see if you can beat me. So there's our first one. That one should be really easy. The second one should be fairly easy also because we've done that. And the third one is one of the new ones. All right, so let's do them. So this is a number, a binomial that is the same terms, one positive and one negative. So this goes back to a perfect square minus a perfect square. So these two multiplied together give you 25y squared. The middle terms are exactly the same but opposites, so they're going to drop out. Your last term is negative 9 and you're done. All right? If you can remember the pattern for squares, then all you do is you take, this is an a plus b squared. So right here, so first term squared. First term is 4a. So 4 times 4 is 16, so you've got 16a squared plus 2ab. So multiply the 2 together. 7 times 4 is 28a. 28a times 2 is 56a. No, 56a. 28, yes. And then your third term is b squared. B is 7. 7 times 7 is 49. Done. All right. Last one is a little bit trickier. Use your patterns. Pause it and see if you can do it. All right. Did you pause it? Here we go. We're going to use the pattern. This one is a minus, so we're going to use this second pattern. So we want a cubed. Now be careful. This is m n all cubed. So you're going to have the m cubed and the n cubed. All right. Second term is minus 3a squared. So mn squared times b. Okay. So negative 6 times a negative 3 is plus 18m squared n squared. Ha 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 ha. Plus 3ab squared plus 3a is mn. B squared is negative 6 squared. So negative 6 squared, 6 times 6 is 36. 36 times 3 is going to be a positive 108 mn minus b squared. So minus 6, cubed. So you're going to have negative 6 cubed. 6 times 6 is 36, times another 6 is 216. And yes, I did that with the calculator before I got here. All right. So this is your final answer. All right. So you can see that you could have just multiplied that all out and you would have ended up with the same answer. But if you can remember this, this pattern, you can plug them in and it'll go a lot quicker. All right. I think that's all I have for you. I'm going to look just to be sure. That's it. See you soon.